have the idea once we do this and then we do this, that you're just plugging them into different types of equations. You do not need to bring your Physics 1 book with you after today. You can use it to study for the final, so I'm not going to collect it from you until the final. So you can leave that at home, and I'm going to be giving you your next physics book. So we start Physics 2 on Tuesday, and then we'll be up and running with that, trying to get as much done as we can. So that's a harder level of physics, but that's why you're here really. That is a real thing for college physics for people who study engineering or physics or some bachelor's of science degree. Bachelor's of science is always at a totally different level than bachelor's of arts or bachelor's of technology. So the physics book we use is for people doing a bachelor's of science degree. And that would help you with any sort of bachelor's of science. So on Monday, you can leave your Physics 1 book home. I'm not giving you your Physics 2 book, so you don't have to carry both of them today. Physics 2 book is much heavier than your Physics 1 book, so we'll spare you a little bit of that. So let's look at your card. Double angle formulas. Sine 2 alpha, okay? If we take our sine alpha plus beta, and we replace beta with alpha, then we get sine 2 alpha. And we have this equation, sine alpha, cosine alpha plus cosine alpha, sine alpha. All right, so let's say you know what the sine and cosine for alpha are, but you don't know what they are for twice the angle. That would be when you would use this equation, okay, by breaking it up. These equations are actually easier to work with than the sum and difference formulas because they're just shorter. Now we simplify this and we get 2 sine alpha cosine alpha. So that's an easier one to work with. So these double angles are easier than the sum and difference ones. Similarly, cosine alpha plus alpha, if we replace alpha, cosine alpha plus beta, if we replace beta with alpha, we get this. And then we plug it in to so what we're doing is building these double angle formulas from the sum and difference formulas. So we're taking the sum and difference formula, replacing beta with alpha, plugging that in, and plugging it in and then simplifying. Similarly, we have cosine alpha plus beta. We write that out, but we replace beta with alpha. So we get cosine alpha minus sine alpha, sine alpha. That gives us this equation, cosine squared alpha minus sine squared alpha, which is your second one right here. Cosine 2u is cosine squared minus sine squared. I can take any one of these and rewrite them in terms of, I can rewrite cosine squared in terms of 1 and sine squared, or sine squared in terms of 1 and cosine squared. Using our Pythagorean identity, cosine squared plus sine squared is 1. So I took cosine squared and rewrote it as 1 minus sine squared. So I got 1 minus sine squared minus sine squared, which is this. Similarly, I can replace sine squared, which is 1 minus cosine squared. So I replace sine squared with 1 minus cosine squared, and I get this. So for cosine 2 alpha, I have 3 different identical equations. So that is why next to cosine 2 alpha, you have 3 equations. We're only going to use the first one because when you do the first one, you already have your common denominator, so it just simplifies the math. So you don't have to get your common denominator afterwards, you already have it. So those are 3 equations for cosine twice the alpha. So let's say you have a 3, 4, 5 triangle, and you know what it is for, which is like 37 degrees, and then you want twice that, okay? You would use this equation here. Tan 2u, okay, that is another one. Okay, we take the tan alpha plus b. We replace beta. We replace the beta with alpha, so we get tan 2 alpha. Therefore, in that equation, we have 2 tan alpha, right? Because we had tan u plus tan v. If they're the same, we get 2 tan alpha. 1 minus, and if they're the same, it's just 1 minus tan squared alpha. So this is an equation. They're actually, these problems are easier, okay? They're all easier than what you've just been doing. So let's go to the first one that we're going to do, which is number 25 on page 441. Okay, so it says in exercise 25 to 36, find the exact value of sine 2 theta, cosine 2 theta, and tan 2 theta, giving the following information. Okay, we're looking at number 25 on page 441. So then 25 says the cosine theta is equal to minus 4/5. Theta is in quadrant 2. So we start these as we do all the others. You draw your triangle, you put down sine, cosine, tangent. Then we're going to get sine 2 theta, cosine 2 theta, and tan 2 theta. So draw that triangle. You're in quadrant 2. Cosine is minus 4/5. We're working with the same triangles over and over. It never really changes. So you're making a 4 or 5. What's the other side going to be? 3. You have a 3, 4, 5 triangle. You're putting down sine, cosine, tangent. Now, which one is going to be the negative? The 3 or the 4? The 1. It's like this. 4 is the negative. Okay, so then write down your sine, cosine, tangent. And then we're going to start to plug them into these equations. So just have your orange card there. So you should have 3/5 minus 4/5 and 3/4. So let's start with sine 2u. So sine 2u is 2 sine u cosine u. So do that. You have your sine and you have your cosine right here.
Wait, would tangent be negative here?
Yes, it would be. And there is supposed to be a negative there. It's just hard to see.
So where are we looking at the orange paper?
Double angle formulas. So you see sine 2u is 2 sine u cosine u. So we're getting sine 2u. Or 2 theta. So you're going 2 sine theta, cosine theta. It's easier. 2 sine theta, cosine theta. So get that. Lincoln, do you have it?
Negative 24 over 50.
Negative 24 over 25. So we have 2 sine theta is 3/5. Cosine theta is minus 4/5. So 2 times 3 times minus 4 is minus 24. And 5 times 5 is 25. Okay. Now let's do cosine 2u. Cosine 2u is cosine squared u minus sine squared u. So you're squaring the cosine, squaring the sine, subtracting one from the other.
I had that down. I just didn't know. Why do we multiply extra costs? Like 2
Because this is basically 2 over 1. So we're going to go over 2
okay.
Okay, so let's do cosine. So you have cosine squared minus sine squared. So cosine squared minus sine squared.
Wait, I have a question.
Yes, they're all like it. You can use this priority, put this one in that one, we're using this one. So you don't have to put your phone in. Just using that one. Just using cosine squared minus sine squared, so we already have our common denominator. So you have minus 4/5 quantity squared minus 3/5 quantity squared, right? The negative goes away when you square it. You're squaring the numerator and the denominator.
Oh, you square both of them?
Yeah, so 4/5 squared, you get 16 over 25. 4/5 squared is 4/5 times 4/5.
How do you solve for the right side of the equation?
So then you have 3/5 squared, right? So you're squaring the 3 and you're squaring the 5. So what does that give you?
9 over 25.
Right, so we have 16/25 minus 9 over 25, which is 7 over 25. Okay, let's go to the next one, tan 2 theta.
Oh, so you don't have to solve the right side.
So you have 2 tan theta and 1 minus tan squared theta. Now you have to get your common denominator. Show me if you think you got your tangent. Let me get your tangent.
There you go. So, oh.
So you should see that your common denominator is going to be 16. So you have to get that on all three terms, your numerator and your denominator. So you start out with this 2 times minus 3/4, 1 minus the negative of 3/4 quantity squared. So you're going to have a 16 there in that bottom. You have to have all three then have 16. So I have minus 6/4 over 1 minus 9 over 16. So I then multiply this by 16 over 16 and that by 4 over 4. The minus inside the parentheses goes away. How'd you get 48? So we have minus 24 over 16, and then we have 16 minus 9 over 16. Our common denominators are the same, so we can cancel them. Lincoln, do you have it?
There's 24 over 7.
Good. Everybody understand? Okay, just go on to the next one, look at your own page. So we're on 27, we're just gonna continue with the odds. You have a 24, 25 triangle. You can just remember how we did it before. There's only like maybe 4 or 5 triangles they work with.
Are you supposed to take that test?
Why did they?
I did a question. Really? Nobody? I thought this was just added.
These negatives are squared this right, so
Oh.
get that as 16, everything over 16, so 16 over 16 we didn't have this over 16 in order to combine those. They have to be in the same color.
Are we on 26 or 27?
27, I might have just said 26, I was gonna check that. Yeah, 27. 817. Just draw that. By now you might have that other side memorized. In quadrant 2. What's the other side of that triangle? 15. It's an 8, 17, 15. So just like the other one, we have this. Put down sine, cosine, tangent. And then plug them into the 3 equations. So you should have this. Sine is 8 over 17. Cosine is negative 15 over 17. Tangent is negative 8 over 15. Sine 2 theta. Jessa, did you get it?
I'm still trying to
Okay. Connor, do you have sine 2 theta?
Hit 240 over 289.
Good. It's negative 240 over 289. You're doing cosine. goes easier when you do cosine. You already know 17 times 17. And then do tangent, and then just go on to the next one.
So, negative 6.5.
Sine theta was 8 over 17. Cosine theta was minus 15 over 17. Did you have that?
Oh, I did 26. I was wondering what I'd be doing.
I started out describing that triangle. I was distracted. But then I said it was 27. Naomi, do you have cosine 2 theta?
151 over 281.
151 over 289?
61.
Yeah, it's 61. You have 15 squared is 225. 8 squared is 64. You have 225 minus 64. Sorry. Did you get that detail? So you're doing tan to theta.
You want us to reduce?
Well, you're going to have to get your common denominator, right? It doesn't reduce once you cancel your common denominator.
Oh, no, I know what I do. 6.5.
So we have this 2 times minus 8 over 15, 1 minus a negative 8 over 15 quantity squared. You already know what 15 times 15 is. So you get this. Your common denominator is 225. So you have to go 225 over 225, 15 over 15. This is 29. $225 minus 64 gives you 161. Once you have your same common denominator, you cancel it, so you get negative 240 over 161. So how do you have to roll this out? And then we're we can find something.
It's on to say, like, it's more than 4.
So the opposite is gonna be negative.
Explain it.
Yeah, so
Sine
she's the
is
first
y.
one to have our common denominator.
So it's going to be positive x negative y. So sine is going to be like gray.
I was just.
29, we have this, it's in the fourth quadrant. Negative 24, 25, 7. See how much faster you've gotten? Should have this, sine is negative 24 over 25, cosine 7 over 25, tangent negative 24 over 7. Just cruising through these problems. That's really good. It should be minus 336 over 625. 25 times 25 is 625. 25 squared is 625.
Oh, I didn't think so.
And the next one, you should have minus 527 over 625, because you have 7 squared is 49 minus 24 squared is 576. 49 minus 576 gives you minus 527.